Hello everyone, today we are going to go over the blind 75 in C++, and today we are working with number of 1 bits. Now before we get started, feel free to pause the video if necessary. For whenever we are going over these types of problems, we need to ask ourselves these 4 questions: what the input's going to be, what data structure / algorithm / technique to use, what to do with the data, and finally what our output's going to be. So we're given the problem: write a function that takes a binary representation of an unsigned integer and returns the number of 1 bits it has, also known as Hamming weight. Okay, that's pretty straightforward. They also give us a couple notes and mention about Java and then also more Java, but we're working with C++, so, well, it's pretty straightforward what they want us to do with the data. They want us to write a function that takes the binary representation of an unsigned integer. And there are symbols that we use pretty much for the technique that we will be doing called bit manipulation. And allows us to get the binary representation of our following for our following input, where it looks like we're given a into 32, so we are given an unsigned integer, and we need to return the number of 1 bits it has. So, looking at this, we just need to scan through all of our integers that we're given for any, well, all the binaries with a given integer, and we return the number of 1s. So the steps for us to be able to go about this, and I will also have a visual at the same time to be able to understand more on what forms of bit manipulation to use, which would be the following. So what we are going to do for our steps are this. Step 1, we have a given unsigned integer. We will create a count to keep track of the 1s. And then what we're going to do is that while scanning through our unsigned integer, if n at the specified index, which is represented by and, equals 1, we're going to increase our count. And then we will right shift the unsigned integer by 1 bit to check for the rest of the bits. And finally, we will return our count. So, the steps for us to be able to go about this: step 1, step 2, and then step 3. Let me just clean this up. Focusing on these steps that we have over here. So step 1, the way how it's going to work, we're going to first create a count. Int count is equal to 0. This is how we first initialize. And then for step 2, well, scanning through our unsigned integer. So the way it's going to look like is that while n doesn't equal 0 specifically, since we have an unsigned integer, A and B, then we'll finally have C for step 3. If n, specifically for 1 at a given bit, equals 1, then we will increment our count, since we are returning the number of 1s. And then what we'll do is that, move B up here, then we're going to right shift, and this is how we right shift. There's also the option for left shift, but since we're not going in reverse direction, we're only moving forward, we therefore use this signal for the right. And finally, we return the count. So let's just run this. All right, passes all the test cases. Let's submit. Okay, now just to give a breakdown on our space and time complexity for the following solution is that the time complexity of this solution is O of log n, where n is the given unsigned integer, and the while loop iterates for each bit in the integer, and while the log n, in which log n bits is the worst case. The bitwise and n right shifting takes constant time. And meanwhile, the space complexity for the solution is O1 because we are not using a data structure to be able to store any of the variables. We're just using a count to keep track of everything. So yes, this was a number of 1 bits. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.